Hello, this is Garrett Keane, continuing the series of videos on programming in Visual Basic for applications. This is the third video I'm doing on the stresses within a thick cylinder, and if you remember from the last one we got to this stage where we used a function. We defined two functions, sigma or and sigma c, which allowed you to calculate the radial and circumferential stress in the thick cylinder shown here. In this exercise I've already got the code in there. I have a code in here which will basically calculate the stresses at intervals along the inner and outer radius. What I'm talking about here is that in the spreadsheet we divide the region from the inner radius R2 to the outer radius into 10 intervals. That's what's done here in the spreadsheet. We have 10 intervals and we come in intervals of 10 millimeters. So you start at the inner radius and you come up to the outer radius with 11 points. If you have 10 intervals, you have 11 points. Also then we calculate sigma or and sigma c at these points, and then we plot them. The whole idea of having 10 points is that you have enough points here to describe to be able to draw the curves with accuracy. In this case 6 points may have been enough, but we did 10 points. What we have in the formula is what we have in the program is we're going to have the flexibility built into it that we can decide how many intervals we actually need as an input value into the program. If I come here and look at the code that I've already done, it's here. There's quite a lot in it. We have option explicit at the top. Calculate stresses is what I call the subroutine. A dimension I as an integer. That's just going to be used as a loop variable. R1 and R2 as before are the inner and outer radii, or the outer and inner radii. P is the internal pressure, and R is the radius position at any point. Num intervals, as I said, the program is going to be flexible in that the number of intervals can be decided. It can be read in from the spreadsheet, and the interval value is then derived from that. That's the difference between the actual distance between any 2 points along the thick cylinder. I define two variables, sigma radial and sigma circum, short for circumferential, as doubles. We're going to calculate these, and we're going to use these variables to store the radial and circumferential stresses as we calculate them using a loop. Then I just come in here and I read what these statements do is they read in R1, R2, P, and the number of intervals from the spreadsheet. So if I run this, F8, R1 is equal to range R1 value, and if I go Control G, print, Control G is the immediate window, and I print R1, you can see it's read it incorrectly, it's 0.2. I'll do R2, P, and num intervals, like so. So we'll print these out, and then if I do it now, these other values haven't been read in yet. So do F8, F8, and F8. Now let's see what we have here. So the inner radius, I'll get rid of this stuff here, and that's the outer radius is 0.2, R2, the inner radius 0.1, the pressure is 10,000, and the number of intervals is 10. But once again, that can be changed. Then I have an output file. Now remember, I'm working on my laptop here, so I'm routing it to a directory called c.vba. You'll have to route that to your own directory, which will probably be sed. And I press F8 here. So I open up an output file called thick cylinder. So what we're going to do here is calculate the sigma or and sigma c at 10 locations like you see in the spreadsheet, but we're going to output the results to a file, to an output file. Okay, so if I go back to the code, F8, I just print out two headings, one for radius, radial, circumferential, the next line will be meters, stress and stress. So they're the headings for the output file. Then I go into the loop itself, where the values are going to be calculated. I have a mistake there, calculated. I just use comments here. The quotation mark will allow me to use comments. And also what's very useful is you putting comments after the statement as well. And you should really line them up like that. So every line there you can put a comment after. I'll put that one out here as well. If you so wish, you can put your comments there. Here we're going to do the loop. and I'm using I as the loop variable, so we're going to go from 0 to number of intervals. 0 corresponds to this point here, the inner radius. Remember, as I said before, if we have 10 intervals, that means we calculate the stresses at 11 points. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points. So what we're going to do in this loop is we'll run from 0 to number of intervals, which is 10. So in fact this will loop 11 times, because you're starting with I with a value of 0. So it'll go 0, 1, 2, 3, 4, 5, 6 up to 10. So in fact it'll loop 11 times. The first time through a loop we say that or, the radius, is equal to or2 plus I times the interval. Well, I is equal to 0. So the first time through the loop there, if I just, what I'll do is I'll just print or here actually. I'll get rid of these and I'll just print or. And it's 0.1. So that corresponds to the first value here, which is 0.1. Then we calculate sigma radial, and I just use the function that we defined in the last video, sigma or, and I pass in p, or 1, or 2, and or, which we just calculated here. I'm just rounding these for output. I'm just rounding them to 3 decimal points using the round function. And you can see when I press F8 here that it brings me into this function here. Now a useful thing you can do here is press F10. Sorry, not F8, what is it? Control F8, is it? No, if we just do F8, it brings me into this one. And then what I do is I print the output file, print #1 or sigma radial and circum. So it puts those to the output file, and you can see it brings me in there every time. So you can see I've gone through there twice. Radius is now equal to 0.11, and it's calculated sigma radial and sigma circumference, and it's printed them to the output file. Now what I can do here is just skip to this point here, F5, by putting a breakpoint in at the side there. Then I do F8, I can get rid of the breakpoint, it's just toggle them on and off. This is very important, you have to close #1. So when you send output to an output file, you also have to make sure that you close that file before the program finishes executing. And I press F8. Now if I come out to my laptop here, and I come to C here, this is where I put the output file, VBA, thick cylinder, I open it up, and you can see this is the output file that the program produces. So you can see here from the spreadsheet, it goes from 10,000 down to 0, and from minus 16,666 down to 666. So if we just check those values here, you can see that they agree, 10,000, 16,667, they agree with the formulae. So we've outputted this value at this spreadsheet here. Now what you can do with that is you can basically go to Excel, we have Excel open, so we can just say open, and I can come in here and I can pick C, if I can find my C directory. Where's it gone to? CCC, down here somewhere, computer, C, and come down here and VBA, and you can see the file is here. So now make sure I switch this to all file so I can see it, all files. There's the thick cylinder, and I open it like so. It says what way do you want to delimit it. I'll use fixed width, which is basically it decides on the fixed width. I say next, finish, and you can see here that it's brought those values into the Excel sheet. So this would then enable you to go and plot these results. What's good about this, writing it as a program, is you can also, the fact that you can decide how many intervals you use means it's far more flexible than coding it into a spreadsheet. Say this time we say we want 6 intervals. You can see automatically the interval size will change. But if I then come back to the spreadsheet and I run it, I can just run it by coming in here and pressing F5. Like something there. I'll tell you why I didn't like that. It's because I have to change this because I have it already open. So if I just stop executing this and I press F5 again and I come out here to my C directory, you can see I've now corrected thick cylinder 1. If I click in here, you can see here now, I should have put some formatting onto here, but you can see here that instead of 10 intervals, we now have 7 points, because I use 6 intervals. So you can see it's far more flexible than using a spreadsheet, because you can determine how many rows you're going to have in it. If I just, while I have it there, I can just tidy this up by, how can I tidy it up? And I can use the format function in here. I'll do it again in a later version. Okay, thank you for listening.